Okay, in this lesson, we are going to learn some basics about what are called box and whisker plots. And box and whisker plots are just another way of basically laying out and organizing a big set of data. Okay, right now, our data, these points don't really mean anything at the moment. They're just some random measurements. It's listed out in a big line. And that's sometimes not the easiest way to recognize special features. So what we're going to do is put into a different kind of plot that shows us certain things we can look for. It doesn't show us everything, but the first thing I want you to recognize is that we are starting with a nice number line down here. And this number line is spread out evenly. Basically the same distance between 10 and 20 as it is between 20 and 30. We're not going to fit the number line to our data. We want our data to be laid out on the number line. The number line is the thing that doesn't change. Now to start with this, what we're going to do is we're going to make sure, first of all, that our data is in order. We start with the lowest and we end with the highest. This is called increasing order. It's the easiest way to organize your data to put it into one of these plots. What we're going to try to do is find the median. The median is the middle value. It doesn't mean it's halfway between 5 and 60. It just means it's the data point that is in the middle of the set. So to find that, it's fairly easy. We just cross off the lowest and the highest numbers until we work our way down to one thing left. So we'll cross off 5, 60, then 8, 50, 11, 47, 14, 40, and so on. Keep working our way down, so hopefully there's just one number left in the middle. And we call that the median. Now, if there happened to be two numbers left in the middle, we would need to find the halfway point between those. Now, on our graph, on the number line, we're going to find the number 28, and we're going to just kind of estimate. It's right about here. I'm going to draw a line at 28. I'll mark the number up here just so that we can tell what it is, since it's not exact on a number. Now, we're going to try to split these data points into 4 equal pieces. It doesn't mean they all span the same range. It means that we have the same amount of data points in each set. So it's like splitting that big long list into 4 equal chunks. So to do that, we're going to find what's called the first or lower quartile. And that's basically the halfway point of this lower section. So to do that, do the same things we did with the median, but we ignore the upper half. I'm going to cross out 28, 5, 26, 8, 21, and 11. And I get 14. 14 is what's called my first quartile, which basically means the first fourth, the first quarter. And I'm going to put that line at about 14, right about here. I'm going to put a 14 right there just to remind myself. Now we're going to do the same thing for the upper half. Let's cut it in half and see where the middle point of that section is. So I'm going to cross off 28, 60, 33, 50, 37, 47. And I end up with 40 as my third quartile. The median could be called the second quartile, but nobody usually uses that terminology. I'm going to find 40 on my number line, and it happens to be at 40 exact. I'm going to draw that up here. Okay, there's my 3 quartiles. Now, to make the box and whisker plot, all we're going to do is connect these, and that makes our box. That tells us where kind of the middle of our data set is. And to find the whiskers, we look for the extremes. Okay, what are the very edges of our data set? It looks like 5 is our lowest number, so I'm going to go find 5 right about here. I'm going to draw what's called a whisker. And over on this side, it looks like 60 is our largest number. So I'm going to draw a little whisker going out to that. And that's a box and whisker plot. Now, what you'll notice here is not everything is equal. Our first quartile, our first quarter, which is this right here, that little section represents 25% of my data points, just in that little spot. This section over here is my fourth quartile. That also represents 25%. That's these points right here. But they're not the same distance. They don't look like they're the same size. That's because some little pieces are more consistent than others. So this is where we get into the analysis part. And in future lessons, we'll talk about how to analyze these gaps once you recognize that each one represents 25% of the data points that I have to work with.